Hello everyone, in this particular video we'll discuss about cleavage of ethers, where most of the students get confused how to write the correct products, and in which case we need to do like via SN1, and where we have to do the products according to the SN2. And most of this, I have seen so many people who got confused. Even myself, when I was in my 12th, I got confused over here. And mm, for make it this concept simple for you, I have divided into few cases. Each and every each and every possibility that I have mentioned it as a one case, so that you will get to know when you have to go for this or when you have to go for SN2. Okay, so start discussing all these things. And if you are a person watching this video, you don't need to see any of the remaining videos. If you watch this particular video on this topic, that I'm giving, I'm sure, okay, that I'm sure you don't need to refer to any other video if you listen to this carefully till the end. Okay, if you think this video is somewhat slow, if you think that I'm teaching somewhat slow, then you can just keep it in 2x speed and you can watch it. Okay, so yeah, let's try to get into this particular topic. So what is the general formula for ethers? This is the general formula for ethers, right? And here R and R dash are any alkyl or aryl groups. Okay, so when you see, generally these ethers are quite stable, they won't react that much. But when we treat it with the strong acids like HI, HBr, it undergoes the cleavage of the bond between the oxygen and alkyl group. So this is where confusion start. Which bond? Like here also oxygen and carbon bond is there with this. It can be any alkyl or aryl groups. Okay, we will solve few questions that you will understand. See, here there is a bond between carbon and oxygen. Here also there is a bond. Which bond do we need to cleave? That is where most of the people get confused. Okay, so that's what you need to understand through this video. So let's say for example, we have got this alkyl halide and this one alcohol. And if you further treat it with again one more mole of HI, this alcohol further get converted into alkyl halide and we will get 2 moles of alkyl halide. Okay, let me explain you the mechanism. Okay, so here what happens? RO, R dash. So this is HI, right? First step is, let me write it over here. Step 1 is protonation. Step 1 is protonation, and here protonation means what? Here this oxygen is there, right? This oxygen tries to abstract this H plus. This is I negative and it will form OH positive. So here we'll get R OH positive and R dash. Now the thing is that where this I minus will get attacked and which bond will cleave. That is the main thing. This I minus act like a nucleophile and it will attack. According to this particular reaction, whatever I have written, this one attack on this particular R dash alkyl or aryl group, and this bond shift towards this oxygen, and here we'll get these products as R OH plus R dash I. Okay, so these are our products. I'll tell you where you need to cleave this bond. So the first step is protonation and the next step is nucleophilic substitution. And here the main confusion starts again. Do we need to do according to SN1 or SN2? So for that I have got one trick. So I'm going to tell you that thing. So the trick is that I have mentioned in the first slide. So whenever you have primary or secondary carbons, so here I am talking about those carbons which are attached to the oxygen atom. Okay, if you have primary or secondary carbon atoms, then it undergoes according to SN2. Okay, in case if it contains any tertiary or benzylic or allylic, like if there is any possibility of forming these benzylic, allylic or tertiary carbocations, then it undergoes according to like SN1. I hope this it's clear for you, right? This is what I have written over here. I didn't mention here benzylic and allylic. Here I have told you, right? So this is the simple trick that you need to know in order to write the products of any of the question regarding like cleavage of ethers. Okay, so here let's try to discuss each and every case. So first one is symmetrical ether. So there is no confusion over here in case of symmetrical ether. First, what you will do protonation, means this will abstract this hydrogen and it will form this OH positive, right? OH positive. And then what happens in the next step? Nucleophilic substitution takes place. I mean, this nucleophilic attack takes place. Here you can cleave this bond, or like this can attack over here on this carbon, or it can attack over here also, because both are same. So it doesn't matter where you are like attacking. So let's say for example, nucleophilic attack takes place on this carbon. This bond shift towards oxygen and it will form an alcohol, and this will form an, here it will form OH and this will form I. What is this? What is the name of this compound? Ethanol, right? So what is the name of this compound? Ethanol. And this one, ethyl halide. Okay, ethyl iodide. Okay, so I hope it's clear. This is in case of symmetrical ethers. There will be no confusion, because both are symmetrical carbon. Wherever you attack, we will get the same products only at the end. So in second case is unsymmetrical ethers. So in case 2, I have made into again A and B, because see, in case of unsymmetrical ethers, this is important. Unsymmetrical ethers means across across this oxygen there will be two different alkyl groups or aryl groups. Okay, here we have this ethyl group, here we have this isopropyl group, so first what happens, again protonation occurs. This will form OH positive. I am writing this protonation step directly. I hope you have already understood that part, right? Because first we'll do protonation, so we'll get this one. In the next step, what happens? This I'm negative nucleophilic attack takes place via SN2 here. Why? Because see, SN2 means it prefers less hindered environment. Okay, so it prefers less hindered environment. So this I negative will attack. Where it will attack? It will attack on less hindered carbon. So obviously it will attack on this carbon rather than this, because it is having more hindrance because it is having two methyl groups. Here it is having only one methyl group. So here it can attack easily. This bond will cleave and we'll get this product CH3 CH2 I. What is this? Ethyl iodide, and again we'll get CH CH3. This is OH, right? This is isopropyl alcohol, or you can also call it as 2-propanol, and this is ethyl iodide. Okay, so here what is the main thing? Here it occurs according to SN2, and as we know that SN2 I have already discussed in my previous videos. If you want, you can watch that particular video where I have explained SN1 and SN2. So yeah, you can refer that particular video, and it prefers less hindered environment. So why I have made into case A means, like here this carbon is what? Primary, right? Because it is attached to only one carbon, and here this carbon is secondary because it is attached to two carbons. So as we know that it prefers less hindered environment, so I negative will attack on the primary carbon rather than secondary. Let's say for example we have both primary, let's say, see, this is also unsymmetrical ethers only because we have two different alkyl groups across this oxygen, but here the carbons, so here this carbon also primary and this carbon also primary. You might get confused in this case also, that's why I have made it into a different case uh, overall, like, right? So I want to just cover all the cases, so that whenever there is a question they'll ask, you won't get confused anywhere. So first step is protonation, OH positive, and in the next step, again this also occurs according to SN2. As I have already discussed, it prefers less hindered, and this ethyl group is smaller group, right, as compared to propyl group. So this I negative will attack on this particular carbon and this bond will get cleaved and it shift towards this oxygen, and here we'll get CH3 CH2, again ethyl iodide, and CH3 CH2 CH2 OH. This is, what is the name of this one? Propanol, right? Propane one all. You can write it like that. So the main idea is this. So this is the why I have made it into case B. In case 2 means see, it is also unsymmetrical ether only, but the thing is that here the both carbons are primary. So in above case both carbons are different. With this is primary and secondary. As we know that if it occurs according to SN2, it prefers primary only, because what is the order of what is the rate of reactivity? Methyl halide greater than primary, then secondary, then tertiary. This is for SN2, right? So you can definitely, this will attack over here, then you'll write the product. But if they give this type of situation where both are primary carbons, then also it prefers less smaller group, you can say. So it prefers smaller group, it attacks over here and we'll get this products. Okay. And if you further, I have told you in the first while explaining the uh, general reaction, I have explained you, right? If they give one more mole of HI, again protonation occurs for this thing. This one will get protonated and it will form the CH3 CH2 CH2 OH2 positive. And as we know that water is a good leaving group, so this I negative will attack over here and this will leave, and we'll get the CH3 CH2 CH2 I. So here we'll get both alkyl halides. Okay. So whenever if they give excess of HI and ether, you don't need to do anything. Simply break the bonds. Simply break these two bonds and add I, or like if they give HBr, just add that halide to that carbon. So here we have added halide and here also we have added halide. But in case if they give only HI, that you need to take care of which one, like what are the types of do we get which type of alcohol, which type of halide we'll get, that you can know through these cases. Okay, I hope you have understood this case also simple. And let's see one more case, case 3. This is ether. This is the case where ethers with tertiary group. Okay, here we have tertiary, and I hope you have remembered the trick. Whenever we have tertiary or benzylic or allylic there is a formation of these carbocations. It occurs according to SN1. SN1 ka rate of reactivity is what? Tertiary is greater than secondary than primary. What is SN1? First it will form, that it is a two-step reaction. It is a two-step reaction, right? First step is what? It will form a carbocation, and then next step, nucleophilic attack. Okay. So these are the two steps in this particular SN1. So here what happens? So here also first step is protonation. What is the protonation? This subtracts like hydrogen, and it will form this CH3 O CH3CH. I am just mentioning CH3 as this, don't get confused. Okay. Then in the next step, what happens means cleavage of bond takes place. Before a nucleophilic attack takes place, the cleavage of the bond takes place and it will form a carbocation. Here it occurs according to via SN1. Here this bond shift towards oxygen, and here we'll get methanol and it will form a carbocation, tertiary carbocation. As we know that tertiary carbocation is more stable, right? Why tertiary carbocation is more stable? These are methyl group CH3, CH3, CH3. So here how many alpha hydrogens are there? 9 alpha hydrogens are there, right? And through hypoconjugation and also through inductive effect, this carbocation is getting stabilized. So let's see, just don't make it complicated when it comes to GOC. This is the electron deficient. It needs electrons, right? So these groups are trying to give the electron cloud towards this carbocation. So anyhow it gets stable, right? So yeah, we have got this tertiary carbocation. And now nucleophilic attack takes place on that particular carbocation. It will attack over here and we'll get this CH3OH and we'll get this tertiary butyl iodide, or we can say CH3 and here it is I. This is tertiary butyl iodide because 4 carbons are there, right? So yeah, I hope you have understood. Here what we have did, here this is the trick. Whenever there is a tertiary carbocation, whenever there is a possibility of forming tertiary carbocation, we have to do according to SN1. So first protonation occurs and then cleavage of bond takes place, and then it will form a carbocation. So after forming a carbocation, this I negative will attack on that particular carbocation and will get these two. Okay, I hope you have understood this one also. And in the next case, which is aryl ether. So the next case is aryl ether. So here the thing is that I have already written the products. Okay, let me explain you over here what is happening. This is methoxybenzene, right? First step is what? First step is simple protonation, that you can do it. Okay, the lone pairs on the oxygen will capture the H plus. Okay, just don't mind here the arrow. Okay, O CH3 OH positive, and here in the presence of like I negative acts like a nucleophile, and the thing is that where it will attack. See here, this also occurs according to SN2. Okay, it prefers less hindered carbon. Anyway, see here what is happening. Let me draw it like this. O positive OH. I'm writing just OH like this. This is the bond between, one bond is there between O and H. Okay, I don't get confused over here also. So the thing is that here PHO bond, this is benzene, right? So here due to the resonance, what is happening? It is forming a partial double bond character over here. So partial double bond character means it is hard to break this bond. So that's why we can't break this bond over here. That's why what happens, this I negative will attack on this carbon and this bond shift towards this OH, and here we'll get phenol and methyl halide, methyl iodide over here. Okay, what is happening here? There is a partial double bond character. Due to that, it is hard to break this bond. That's why I negative will attack over here on this carbon. So we can't leave this bond that much easily. Okay. So I hope you have understood this case also. Whenever there is a possibility of thing like this, then we'll get a phenol and a methyl iodide. Okay. And the next case is in case of benzyl ether. In case of benzyl ether, I have told you, right, the three cases: in case tertiary or benzylic or allylic. So in case of these three, whenever there is a possibility of forming tertiary benzylic or allylic carbocation, then it occurs according to SN1. Here also this is S. Okay, so here let's see this case. Here it is a benzyl methyl ether. I have written the products directly again. Here what happens? This CH2O CH3, right? And in the presence of HI, what happens here? This is the protonation, right? So here CH2O CH3 protonation occurs, and then in the next step what happens? It forms a first, it is occurring according to SN1, right? So what will happen here? It occurs according to SN1. So what happens here? This bond will cleave first and it will form benzylic carbocation CH2 positive, and then we'll get this methanol. Okay, so this benzylic carbocation is stable because it is resonance. Due to the resonance, this benzyl carbocation is getting stabilized, right? So resonance, how it is happening? I hope you know this thing, right? CH2 positive. Through resonance, it is getting stabilized. So next step, what happens? High negative will attack on this particular carbocation. Here we'll get CH2 high benzyl iodide. I hope this is also clear. First, it will protonate, this oxygen gets protonated, and then cleavage of bond takes place. After that, it will form this benzylic carbocation. This is benzylic carbocation. Okay. benzylic carbocation. I'm just writing like this, and then like nucleophile attack takes place. I negative will attack on this particular carbocation, and will get this benzyl iodide. And I hope you have understood. We have did according to SN1. The last case is this. Let's try to understand this last case, which is allyl ether. Okay. So in case of allyl ether, also same thing happened. First the protonation occurs, then after that bond cleavage occurs. So let's try to understand over here. First, this is Hi, and here what happens? This will get protonated by abstracting this H plus, and here it will form this O OH positive, and then afterwards what happens? This here this bond cleavage occurs. This bond shift towards this oxygen, and it will form this carbocation. Allylic carbocation it will form, and then this ethanol will get. Okay. Here this allylic carbocation also, here this allylic carbocation is also stable because of resonance, right? It is resonance stabilized, that's why it is more stable. And then I negative will attack over here, and then we'll get this product allyl iodide. So I hope you have understood all these different cases, and few special cases are there. I mean, there is a, like, again you might get confused. So these are the few special cases that I'll explain in my next video. So first try to understand all these things, whatever I have explained you. Just try to have an idea about that particular trick. So whenever there is a possibility of forming tertiary benzylic or allylic carbocation, then it undergoes according to SN1, or else it undergoes SN2. SN2 prefers less hindered environment. Okay, I hope you have understood the concept in detail. So yeah, that's it for this particular video, and we'll meet and discuss few more special cases. And yeah, that's it for this particular video. Take care of yourself, and be kind. Bye.